this is an emerging discipline of how to make sure that your artificial intelligence delivers the objectives that your organization wanted it to. And what we've done in this presentation is pull together a little bit of context that can help you prevent your AI from going wrong. The presentation is based upon lots of experience in enterprise cybersecurity, in delivering artificial intelligence, and also in doing assessments for corporations in multiple industries on how to better protect their intellectual property, but also their algorithms and their models and their data. So what we did in pulling this presentation together is also look at multiple sources of information, not only our direct experience, although that certainly informs everything we do, but also the research that we write and publish on our site. And increasingly, this is a subject that we're able to tap into that's being studied by the big IT firms and academia. The IT firms, as you can imagine, Google, Microsoft, IBM, are putting a lot of money into figuring out how to deliver AI more securely. Oh, Amazon as well. And this is all good. It's really helpful. Although, as you can imagine, when a big firm invests money in that, they're mostly thinking about their solutions. So you need to look at all the big firms is the key point we're seeing. And a very optimistic, positive source that I'm really excited about is academia. If you look at all of the major institutions that are focusing on not just computer science, but the discipline of artificial intelligence, they already have courses now where we're teaching the young developers about ethics in AI and security in AI. So although there's still a lot of problems and challenges today, it's a very positive thing that academia is taking this so seriously. But we have tapped into them as a source. Now, based upon the sources that we've encountered, we first wanted to provide a little bit of context, just level setting to make sure that all of us talking about this today are thinking of the same thing when we use these words. Artificial intelligence itself, as we have seen through the multiple AI World conferences, there's a lot of different definitions depending on how you're using AI and what you want to get from it. There's academic definitions, or there's definitions designed to fit a particular use case. I want to talk about AI from a practitioner's viewpoint. So from the practitioner's viewpoint, AI is something applied to real-world problems. So I define artificial intelligence as the application of thinking machines to real-world problems. That's a little bit different than the academic definitions, and those are okay, by the way. You need to have those. But here we're talking about real-world problems, and if you define it in this practitioner's way, it lets you think about much more than just the algorithms at play, and you really need to do that if you want to think about preventing problems. So on the next slide, I'm going to say, here is what this definition can do for you and why it's a little bit different. But keep in mind, I'm thinking about this in the context of a practitioner's view. If you take a practitioner's view to artificial intelligence, it just underscores that it's about far more than just the algorithms. It's about both technology components and non-technology components. Now, in the technology component list there, I mean, algorithms are certainly important. They're incredibly important, but they're not the only technology. We also need to understand the many other things that go into AI solutions, which, depending on the enterprise and the solution, might include robotics, probably, very likely, depending on the kind of solution you're using, computer vision. It probably requires some sort of data architecture, a special ETL transformations and data cleansing. It might include interfacing to sensors. It very likely includes some new architectures for storing data and moving data and processing on data. So the hardware architecture needs to be understood if you take a systems view. And then there's the technical security measures. There's a lot of non-technical security measures, but the technical ones will include how do you encrypt data, or what technologies do you use for granting access and for management policy.